This video will focus on the learning targets. I can explain the difference between heat and temperature. And then also I can determine the system versus the surroundings, endothermic and exothermic, and also energy sign conventions correctly. So again, the study of heat energy is called thermodynamics or thermochemistry, okay? And heat as a variable that we talk about is called thermal energy. So it's energy specifically due to the motion of particles, because the motion of particles give that thermal energy. Also, it has to do with making more possible motion, which is the potential component. And the variable for heat is Q. So within a within a equation, if we want to denote heat, we use the letter Q for thermal energy. And then the label for Q is joules. So within thermal energy, there's two forms of thermal energy. We have kinetic energy, which is that motion energy, right? As I move more, I have more energy, or more energy causes more motion. But then also there's potential energy also. And in this case, there's the potential energy for motion due to the arrangement of the particles. So unlike physics, where we often talk about kinetic and potential in relation to like that roller coaster idea, right? That when you're on the top of the roller coaster, you have more potential for motion. Thermal energy has to do with the motion of the particles. So it's not a question of gravity, it's a question of how the bonds are arranged that allows for that potential motion. Okay, and there are ways to calculate this that we'll get into. Now, also the thing that's important, and this is really fundamental to this unit and the calculations, is identically to the conservation of mass, we also have a conservation of energy. So energy is never created or destroyed, it's simply transferred. So if one object is losing energy, something else is gaining energy somewhere. And because of that, we can set up experiments to calculate something that otherwise would be impossible to calculate. So it's kind of a cool concept. Now, heat versus temperature. We've already talked about how temperature is a measure of average kinetic energy, which means temperature has to do with that motion component of thermal energy, right? As I'm moving more, I have more kinetic energy. But heat or thermal energy is all of the energies, right? The kinetic as well as the potential. So heat and temperature are not the same thing, okay? Which is weird. It's a weird thing in your brain because you're used to thinking of hot as temp, as a like temperature is a way to measure hot. And that's like true, but it doesn't measure the potential. So there's this other component that has to do with heat energy that we have to be aware of when we're doing calculations. Because essentially you can gain more heat without changing the temperature, because you could be gaining potential, right? So it's a little bit something to be aware of. So when I think about heat and temperature and want to compare them, here are the things that I think of. So number one, temperature is measured in like Celsius or Kelvin, where heat is measured in joules, because heat is a measure of energy, where temperature has a direct relationship with energy, but it is not energy in itself, right? It's a question of motion that has to do with its temperature. So temperature is not energy while heat is energy. Okay, and then temperature also is only kinetic. So as I increase my speed of my particle, I increase my temperature, which does increase my heat. But heat not only has to do with the speed, but also that potential. So if I change the potential, I can change my heat without changing my temperature. Okay, within this unit, we'll be using both variables because obviously if I change my temperature, I will change my heat. But we'll also have a way to calculate when temperature isn't changing, but the potential is, so heat is. Based on that law of conservation of energy, that energy is never lost, it's simply transferred. Oftentimes, when we're trying to analyze a problem, we will need to identify what the system is versus the surroundings. Okay, so when I think about this, I think about the fact that, like I already said, if an object is losing energy, that means another object is gaining energy. So we often label those the system and the surroundings. So if what I'm talking about, the system, is losing energy, that means the surroundings, the thing around them, is gaining energy. It's being transferred out to it. Or if my system is gaining energy, you're like, where is it getting energy from? Well, it's getting it from the surroundings, okay? So that is something that we'll use in our calculations. Okay, point 2 on here, energy always moves from high to low. Okay, just like kind of the idea of osmosis, we always move from high concentration to low concentration. Same with energy. Energy will always move from high energy to low energy. So sometimes that'll be hot to cold. It'll frequently be hot to cold, but again, potential. Energy always stops moving once the temperatures of both systems are the same. So there's not like a net Q that we're looking at here. Temperature does drive. So like, for example, if you put hot water out on the counter, it's going to cool off until it gets to room temp, till the surroundings, the temperature around the water is the same as the system, the water itself. Okay. So what that means is if I can calculate how much energy my water gives off into my surroundings, that means I know how much the surroundings gained. So this last point of Q equals negative Q is something that we'll use in calculations. Now, a couple reminders about terms, endothermic and exothermic. Most of you know what they are. Endo means energy in, so your object, your system, is gaining energy from the surroundings, okay? And sometimes people think of these as like hot and cold, but I'd caution you away from that, okay? Again, I would just think about the direction energy is moving. And endothermic energy is moving in, which means the object itself is gaining in energy and the surroundings is losing. So what's weird about that is we usually think of endothermic as cold, because if we touch something that's gaining energy, oftentimes you're feeling cold. But what you're actually feeling is the surroundings, is feeling the absence of heat, because the surroundings is getting energy pulled into the system. So the surroundings is actually going down in energy. Okay, it's a weird concept. So we often think of endothermic as cold, but I would caution you away from that, because an endothermic object is gaining energy. So it could actually get hot. Okay, but it feels cold because you are the surroundings and you are losing energy. So exothermic is the opposite, right? Exothermic is when we're releasing energy out into the surroundings. So if you put your hand in the surroundings now, you will feel an increase in energy from the system into the surroundings. So the system itself is actually losing energy, but you're feeling the heat coming off of it, which is why you often think of exothermic as hot, but you shouldn't. Just think about it in relation to losing energy. Okay, surroundings are gaining energy where the system is losing energy. Last thing about this video then is the sign. So when we think about energy, when something is losing and something is gaining, the way we talk about that convention in chemistry is with the negative sign. Okay, so if I'm gaining energy, that means I'm gaining positive Q, and so my heats will be positive. And if I'm losing energy, the way we denote that is with a negative. Okay, that doesn't mean negative energy, right? There's no such thing as like the absence of it, but what it means is direction, right? I'm losing it from here and somewhere else it's being gained. So negative heat or negative Q just denotes the fact that that object released that amount of energy and it was gained somewhere else. So negative Q means it's exothermic, energy was coming out from system to surroundings, where positive Q means it was coming in. Delta H is that other sign for heat, just denoted as enthalpy, which is something we use in calculations. So there's an overview of a lot of little things: heat versus temp, endo and exo, the sign convention, and then system and surroundings. Go ahead and do the quiz and have a nice night.